Hello, everyone. This project is based on analysis of GDP per capita as an indicator for electricity production using renewable energy sources from 1990 to 2014. The group members include myself, Rahul Muni, Ryan Walker, and Jack Chen. I would like to thank Professor Rajesh Jugulam and teaching assistant Sarvesh Sundaram for their much needed guidance throughout the semester. Starting with this project, our project is based on renewable energy sources. We are concentrating on electricity production from 1990 to 2014. The goal of this project was to analyze the significance of GDP per capita as an indicator of the adoption of electricity production from renewable energy such as wind and solar. We assumed that countries with a similar level of GDP per capita would have similar levels of electricity production from renewables as a part of total electricity production. The United States, Japan, France, and Germany were the countries which were selected by us. These countries had a similar levels of GDP per capita in 1990. So, if our assumption was correct, their mean production of electricity from renewables over a period of time should be similar as well. We took data from 1990 to 2014 and used statistical analysis to compare these countries and to determine the significance of GDP per capita as an indicator of electricity production from renewables. P diagram. Parameter design is the cornerstone of Taguchi's robust design philosophy. Mr. Genichi Taguchi had developed this philosophy. Taguchi methods have been widely used to improve the robustness of engineered systems. Parameter design classifies the inputs, outputs, and the ideal functions of a system. P diagrams are used to capture information and provide a convenient framing mechanism. It helps in identifying the element of interest transfer function that translates input into desired system response. It requires careful analysis of inputs, outputs, control factors, and noise factors. P diagrams facilitate understanding of design and control factors that may be adjusted to maximize a system's robustness. If properly executed, P diagram provides robust system design, optimal performance, rigorous understanding of the control factor, trade space, and impact on understanding requirements. The P diagram for this particular project concentrates on the inputs such as energy, water, raw materials, and nuclear sources. Gas, coal, and oil are used in the process for the infrastructure. The noise factors include geographical location, climatic conditions, civil unrest, economies of scale, public opinion. So these are the noise factors which we had considered for this particular project. Control factors include capital costs to build technology, higher construction costs, energy policy, energy budget. The process of all of this combined is for producing renewable energy. The output, we get electricity using the renewable sources. This is what the P diagram is.
Hey everybody, my name is Ryan Walker, and I'm here to talk to you a little about some of the statistical tools that we utilized in determining whether or not GDP per capita is a significant indicator for electricity production from renewable energy sources. So here we have a time series graph with the x-axis showing the years from 1990 to 2014, the y-axis showing the percent of total electricity production for the four countries, Germany, France, Japan, and the United States, and their corresponding 25 data points. Now, from 1990 to 2001, all four countries are more or less comparable. And right around that time, Germany starts this upward trend that indicates something with Germany changed. Now, interestingly enough, right around that time is when Germany ratified the Kyoto Protocol. So this may be a result of a change in their energy policy, trying to meet some of those energy goals related to the Kyoto Protocol. Another point I'd like to talk about on the graph is between 2010 and 2011. There's a big jump in Germany's electricity production from renewable energy sources. And early 2011 is when the tsunami hit the Fukushima nuclear reactor. So this may be a result of the events related to that, maybe trying to dial back the amount of electricity production from nuclear, making a bigger push for renewables over that time. Now, as you can see, all the other three countries stayed more or less stagnant and pretty consistent with each other. Germany is the only one that seemed to really be sensitive to the energy-related policies and energy-related events throughout this time period. Now, here we have a box plot showing the distribution of electricity production from renewables for each country. And to be expected, Germany's distribution is much larger, whereas the other three countries stayed pretty consistent over the time period we looked at. Thus, they have a much smaller distribution. Now, the starred values are representing outlier values, and the line that connects all four boxes indicates the mean for each country. And lastly, the markers for each box just show the median value. Now, here you can see the results from our analysis of variance, or one-way ANOVA that we ran through Minitab. And this should give us an insight as to whether or not GDP per capita is a significant indicator for electricity production from renewable energy sources. So our null hypothesis for this is that all four means would be equal, and our alternative hypothesis is that at least one mean is different. Now, a couple of the key points on here I want to talk about are the mean values down at the bottom. You see Germany at just under 7, France at 1.4, Japan just over 2, United States just under 3. So it doesn't look like there's a lot of consistency between the three of them, but to know if it's statistically significant, we look up at the p-value in the top right corner. You see it's 0.000. Now, since this is significantly less than the alpha value of 0.05, we are going to reject the null hypothesis and accept the alternative hypothesis, that at least one mean is different. Now, this is a good indication that GDP per capita is not a significant indicator for electricity production from renewable energy sources.
Here we see the four plots about the distribution of growth percents from these four countries. We can see the German one is more different than the other three. When we ignore the basis line of growth of the Japan, United States, and France distribution, we can see they are more or less the same. Of course, on the more side, and we think that we can use a positively skewed normal distribution line to better fit its percentage. But on the Germany side, both of the normal distribution and the positively skewed normal distribution cannot fit, as there are too many anomalies. In conclusion, we can see the time series show that each country have increased production of renewable electricity sources over the time period. And from the box plot, we can and the histograms, we can see that Germany is different from the other countries in the percentage distribution, and we can see France, United States, and Japan. These three fit more into the positively skewed normal curve than the usual normal curve. But for Germany, it's pretty hard to find a better curve to fit it, since there are too many anomalies. And from the ANOVA results, which is more statistical, we can see that p-value is close to 0. So we not only have to reject the null hypothesis, which means GDP is not a pretty good indicator of renewable energy production, and we can see that these two may not be that related due to the p-value close to zero. So we have to consider other variables that needs to be considered, such as energy policy, which is more the case in Germany, and the public opinion, which might will be more case in Japan, and geography or climate, which is uh, from a small sample size that we may have some similar noise factors affecting the results. So finally, we can see that from the trends displayed in the time series, that we can see a similar progression in the three countries except Germany that we studied. And GDP per capita is not very significant in determining our renewable energy production. We need to resort to other variables, such as Fukushima nuclear reactor that affects not only Japan but also Germany, the anomalies in Germany. And from that, we can see that uh, there may be a push from that to uh, inside other countries to make a transition from nuclear power to renewable energy, which is very likely to be, a problem from public opinion, especially in Japan, as of the time, most of the population think that they need to stop using nuclear energy. But that's the odd part, since Japan's trend wasn't that much affected. Maybe it's because the large companies, they stay the course even though the public opinion changes. From this conclusion, we may get some useful information in determining how we can best promote the adoption of our electricity production into renewable energy. Thanks for